Welcome to the Healthy Pantry, where we delve into the fascinating world of nutrition and its profound impact on our health. Today, we're exploring a topic that's as intriguing as it is important: how sugar affects the brain. Join us on this journey as we uncover the science behind sugar's influence on our most complex organ and discover why understanding this relationship is crucial for our well-being. Let's begin. First and foremost, when we consume sugary foods, such as candy, cookies, or soda, it sets off a cascade of biochemical reactions in our brain, one of the key players being dopamine. Dopamine is often referred to as the feel-good neurotransmitter because it's involved in our brain's reward system, signaling pleasure and reinforcement. Here's how it works. The sweet taste of sugar activates our taste buds, sending signals to the brain's reward center, particularly the ventral tegmental area, VTA. In response to this sensory pleasure, the VTA releases dopamine into the nucleus accumbens, a region associated with reward and reinforcement. This dopamine release creates a sense of pleasure and satisfaction. The brain associates the consumption of sugar with pleasure and reward, reinforcing the desire to seek out and consume more sugary foods. Over time, this can lead to cravings and even addiction-like behaviors. Just like with other addictive substances, repeated exposure to sugar can lead to tolerance, where the brain becomes less sensitive to the effects of dopamine. This desensitization means that more sugar is needed to achieve the same level of pleasure, contributing to overconsumption. When sugar intake is reduced or eliminated, individuals may experience withdrawal symptoms similar to those seen with other addictive substances, such as irritability, cravings, and mood swings. What's more, cravings and addiction are significant aspects of how sugar affects the brain, and understanding them can shed light on why it's so challenging for many people to moderate their sugar intake. As mentioned earlier, sugar consumption triggers the release of dopamine in the brain's reward center. This dopamine release creates feelings of pleasure and reinforces the desire to consume sugary foods. Over time, the brain learns to associate the consumption of sugar with this pleasurable sensation, leading to cravings for more sugar. Sugar can hijack the brain's reward circuitry, similar to addictive drugs. When we indulge in sugary treats, the brain's reward system is activated, reinforcing the behavior and making us want to repeat it. This cycle of reward and reinforcement can lead to compulsive sugar-seeking behaviors, akin to addiction. Like with other addictive substances, repeated exposure to sugar can lead to tolerance, where the brain becomes desensitized to its effects. This means that over time, individuals may need to consume more sugar to achieve the same level of pleasure. Additionally, dependence on sugar can develop, where individuals rely on it to regulate their mood or energy levels. When sugar intake is reduced or eliminated, individuals may experience withdrawal symptoms similar to those seen with drug withdrawal. These symptoms can include cravings, irritability, mood swings, headaches, and fatigue. The intensity of withdrawal symptoms can vary depending on the level of sugar dependence and the speed at which sugar intake is reduced. Chronic consumption of high levels of sugar can lead to neurobiological changes in the brain, including alterations in dopamine signaling and changes in the sensitivity of reward pathways. These changes can further perpetuate cravings and addictive behaviors, making it difficult to break free from the cycle of sugar dependence. Did you know that sugar consumption doesn't just affect the brain through neurotransmitter activity? It also has significant implications for insulin response, which in turn can impact brain function. When we consume sugar, whether it's in the form of sucrose, fructose, or glucose, it gets absorbed into the bloodstream, causing a spike in blood sugar levels. In response to rising blood sugar levels, the pancreas releases insulin, a hormone that helps transport glucose from the bloodstream into cells throughout the body, including the brain. This process is crucial for regulating blood sugar levels and providing energy to cells. Excessive sugar consumption, especially from sources like refined carbohydrates and sugary beverages, can lead to insulin resistance. In insulin resistance, cells become less responsive to the effects of insulin, causing blood sugar levels to remain elevated. This can lead to a vicious cycle of increased insulin production and further insulin resistance. The brain relies heavily on glucose as its primary source of energy. Insulin facilitates the uptake of glucose into the brain cells, where it is used for various metabolic processes, including neurotransmitter synthesis and neuronal signaling. Disrupted insulin signaling and glucose metabolism in the brain have been linked to cognitive impairments and neurodegenerative diseases. Research suggests that insulin resistance and high blood sugar levels may increase the risk of conditions such as Alzheimer's disease, dementia, and cognitive decline. If you find this video helpful and informative, please support the Healthy Pantry channel by leaving your comment below, liking this video, and subscribing for more daily health and nutrition tips. But wait, there is more. Sugar consumption can contribute to feelings of brain fog and fatigue due to its effects on energy levels and cognitive function. When we consume sugary foods or beverages, they can cause a rapid spike in blood sugar levels, providing a quick source of energy. However, this energy boost is often short-lived, as the body responds by releasing insulin to bring blood sugar levels back down. This rapid decrease in blood sugar levels can lead to feelings of fatigue and lethargy, commonly known as a sugar crash. High intake of sugar, particularly refined sugars and carbohydrates, has been associated with impaired cognitive function, including decreased attention, memory, and processing speed. Research suggests that fluctuations in blood sugar levels, such as those induced by consuming sugary foods, can impair cognitive performance and contribute to brain fog. Consuming large amounts of sugar, especially close to bedtime, can disrupt sleep patterns and impair sleep quality. Poor sleep can contribute to feelings of fatigue and cognitive impairment the following day, exacerbating brain fog and reducing overall cognitive function. Moreover, excessive sugar consumption can lead to inflammation in the brain, which has been linked to various neurological conditions and cognitive impairments. High intake of sugar, particularly refined sugars and carbohydrates, can trigger inflammatory responses in the body, including the brain. Consuming sugary foods leads to an increase in pro-inflammatory molecules, such as cytokines and chemokines, which promote inflammation in the brain. Sugar metabolism can generate reactive oxygen species, ROS, leading to oxidative stress in the brain. Oxidative stress occurs when there is an imbalance between the production of ROS and the body's ability to neutralize them with antioxidants. Chronic oxidative stress can damage brain cells and contribute to inflammation. The blood-brain barrier is a protective barrier that regulates the passage of molecules between the bloodstream and the brain. Excessive sugar consumption has been shown to disrupt the integrity of the blood-brain barrier, allowing inflammatory molecules and toxins to enter the brain more easily, further promoting inflammation. Microglia are immune cells in the brain that play a key role in the immune response and inflammation. High sugar intake can activate microglia, leading to the release of pro-inflammatory cytokines and perpetuating neuroinflammation. Chronic activation of microglia has been implicated in the development of neurodegenerative diseases. Neurogenesis, the process of generating new neurons, is crucial for brain health and function. Chronic inflammation induced by excessive sugar consumption can impair neurogenesis, hindering the brain's ability to repair and regenerate itself. Lastly, the gut-brain axis is a bidirectional communication system that connects the gut and the brain, allowing them to interact and influence each other's function. The gut is home to trillions of microorganisms, collectively known as the gut microbiota, which play a crucial role in digestion, nutrient absorption, immune function, and even mood regulation. High sugar intake can disrupt the balance of gut bacteria, favoring the growth of harmful bacteria and reducing the abundance of beneficial bacteria. This dysbiosis in the gut microbiota can negatively impact brain function and behavior through the gut-brain axis. High sugar intake can increase intestinal permeability, also known as leaky gut syndrome, where the lining of the intestines becomes more porous, allowing harmful substances such as bacteria, toxins, and undigested food particles to leak into the bloodstream. These substances can trigger immune responses and inflammation, which can affect brain function and behavior through the gut-brain axis. Moreover, leaky gut can lead to systemic inflammation, which has been implicated in the development of various neurological disorders. Overall, the gut-brain axis plays a critical role in maintaining homeostasis and regulating various physiological processes, including brain function and behavior. Excessive sugar consumption can disrupt the balance of the gut microbiota, promote inflammation and intestinal permeability, alter neurotransmitter production, and dysregulate hormonal signaling, all of which can impact brain health through the gut-brain axis. Maintaining a balanced diet low in added sugars and rich in fiber, probiotics, and prebiotics is essential for supporting gut health and optimizing brain function. So there you have it, folks. We've taken a deep dive into the intriguing ways that sugar affects our brains. From the initial dopamine rush to the potential for addiction-like behaviors, sugar's impact on our brain chemistry is undeniable. But it's not just about the short-term pleasure. Excessive sugar consumption can lead to long-term consequences, including inflammation, cognitive impairments, and even increased risk of neurological disorders. The good news? Armed with this knowledge, we can make empowered choices about our diets and lifestyles. By opting for whole, nutrient-rich foods and minimizing added sugars, we can nourish our brains and support our overall well-being. Take care, and see you tomorrow in the next video. Thank you for joining us here at the Healthy Pantry. We hope you found the information valuable and inspiring. Remember, your health is a journey, and we are here to guide you every step of the way. Thank you for watching, and we will see you in the next video.